This video is over section 9.1 inverse functions. So before we start, we need to talk about a few vocabulary words. A one-to-one function is if for any a and b, in the domain of f, I'll say the function f, if a is not equal to b, then f of a is not equal to f of b. Or equivalently, you could say f of a equals f of b, then a equals b. I'll say if f of a equals f of b, then a equals b. A horizontal line test, so a function defined by y equals f of x is one-to-one if no horizontal line intersects the graph in more than one point. All right, and then lastly, an inverse function. So if we let f be a one-to-one function, then g is the inverse of f if f of g of x equals x for all x in the domain of g, and then vice versa, g of f of x equals x for all x in the domain of f. All right, a lot going on there, but it'll flesh out once we do some problems. All right, determine if the following are one-to-one. So if I have 4, -5, 6, 1, 2, 4, and 0, -3, this function is one-to-one because if I look at my output values, I have -5, 1, 4, and -3. Nothing is repeated, so this would be one-to-one. All right, for this next one, I have 1 maps to A, 2 maps to D, 3 maps to B and C, but no outputs have multiple inputs, so this function is also one-to-one. Lastly, I have this table, -2, -7, -1, -4, 0, -1, 1, 2, 2, 5. Again, no outputs are repeating, so this one is also one-to-one. I meant to put an example of one that's not one-to-one, but that's okay. It would not be one-to-one if I had like 3, 5, because we have 2 5s here. All right, use the horizontal line test to determine if the graph defines y as a one-to-one function of x. So here, if I drew a horizontal line here, notice that it hits 3 times. So this is not one-to-one because it fails the horizontal line test. it hit 3 times. The horizontal line test says it should only hit 1 time. Here, this one passes because anywhere I draw a horizontal line, it only hits once. Or like, for example, right there. So this one is 1 to 1. Let me use blue. Last, I have this circle. If I drew a horizontal line here, for example, it would hit twice. So this is not 1 to 1 because it does not pass the horizontal line test. Okay, great. All right, if we continue on, it says determine whether the functions are inverses. So we need to check 2 things. I'll write it up here, but we need to check 2 things. We need to check that f of g of x is equal to x, and then vice versa. We need to check that g of f of x is equal to x. And if both of those are true, then they are inverses of each other. So let's try f of g of x. And when I do that, I'm going to take g and put it in for x. So that will be 2 parentheses x minus 6 plus 6 on top, all divided by 2. And when I simplify this, I'm going to have 2x minus 12 plus 6 all over 2. So I get 2x minus 6 all over 2, which gives me x minus 3, and that is not x. So this one, I don't even need to check the other direction. This one, f and g are not inverses. Okay, we need to check, well, this one, I hope you understand, m and n would be the same thing as g and f, but let's do m of n of x. So we're going to take n and plug it in for that x right there. So that's going to be 5 over 2x plus 5 over x minus 2. And we need to try to simplify that. That looks really hard. So let's start by, let's multiply the denominator by x. And if we multiply that by x, we need to multiply the top by x. So what that will leave us with is 5x over, here the x's would cancel, so I'd kind of have this big bottom. X's would cancel, so I'd be left with 2x plus 5 minus 2x. When I reduce it, I have 5x on top, and then on the bottom, I'd be left with just 5. And the 5's give us just x, so that direction worked. It's a little sloppy. The other direction would be n of m of x, so I'm going to plug in the opposite direction. So I'm going to take m and plug it in here and here, both the places. So that's going to be 2 times 5 over x minus 2 plus 5 all over 5 over x minus 2. And try to reduce that. So I'm going to have 10 over x minus 2 plus 5 over 5 over x minus 2. When you divide by a fraction, it's the same thing as flipping and multiplying. So let me go over here for more space. So I'm going to have 10 over x minus 2 plus 5 times x minus 2 over 5. I flipped and multiplied. Okay, when I distribute x minus 2, I'm going to have 10 times x minus 2 over 5 times x minus 2. So I multiplied that one. And I'm going to multiply this one, and that's going to be plus 5 times x minus 2 over 5. And when I reduce, it gets a little crazy, I guess. These cancel, and these cancel, and I'm left with 2 plus x minus 2, which is just x, so check. So yes, these are inverses. That got crazy. So m and n are inverses. Okay, that kind of looks like a plus sign, so I'm going to make like an and. Same over here, and. All right. This says procedure to find an equation of an inverse function. For one-to-one function defined by f of x equals y, then the equation of the inverse can be found as follows. Step 1, replace f of x by y. So let's just go ahead and simultaneously read the directions and do the number 1. So this is going to be y equals 4x plus 3. Step 2, interchange x and y. So that's going to be x equals 4y plus 3. Step 3, solve for y. So I'm going to subtract 3. 5x minus 3 is equal to 4y. Divide by 4. And I'm left with y equals x minus 3 all over 4. And then step 4, replace y by f of negative 1. So here I would have my inverse of x is equal to x minus 3 all over 4. All right, this one we're going to replace g of x with y. So I'm going to have y equals x minus 2, x plus 2. Switch my x's and y's, so this is going to be x equals y minus 2 over y plus 2. I'm going to solve for x, so I'm going to put a 1 on the denominator here and then cross multiply, which will give me 2 minus y is equal to x times y plus 2. Let's distribute, so I'm going to have 2 minus y equals xy plus 2x. I'm trying to solve for y, so let's get my y's on the same side and move this 2 to the right side. So these cancel and these cancel. So I'm going to have y minus xy is equal to 2x plus 2. These both have a y, so I'm going to take it out. And when I do that, I'm going to be left with 1 minus x is equal to 2x plus 1. And then divide by 1 minus x on both sides. So I have y equals 2x plus 1 over 1 minus x. And then they want us to write f inverse of x equals, and then 2x plus 1 over 1 minus x. Let's go ahead and box this one too. Great. All right, for the following, we're going to graph the function. Well, we have a lot to do actually, so let's just do it as we read. So for the following, graph the function. So first, when we have n squared equals x squared plus 1 for x is less than or equal to 0. So I know it's a quadratic that starts at 1. So if I plug in a 0, I'm going to get a 1. If I plug in a negative 1, so that would be negative 1 squared plus 1, I would get 2. If I plug in a negative 2, I'm going to get 4 plus 1, which is 5. And if I plug in a 3, I would get 9 plus 1, which is 10, which is off the grid. And we want our x's to be less than or equal to 0, so it's just going to go like that. Great, so part B from the graph, is f a one-to-one function? Yes, it passes the horizontal line test. So I guess we did A. So part B would be yes. We pass the horizontal line test. Part C, write the domain of f in interval notation. So the domain in interval notation would go from negative infinity to 0 included. Part D, write the range of f. So the range, we're starting at 1 included and going up to infinity. Part E says write an equation for the inverse. So part E, we're going to need to do some work. So we have y equals x squared plus 1, and we want to switch x and y. So it'll be x minus 1 is equal to y squared. So the inverse would be the square root of x minus 1. And then part F says graph them on the same coordinate system, which we already graphed the first one. So I'm not going to put F here, I guess. We'll just graph it. Let's graph it in orange. So if we have the square root, what's going to go here? The square root of 1 is... Okay, let's just plug in. If I plug in a 0, I get a negative under the square root, so that won't work. But if I plug in a 1, I'll get a 0 here. If I plug in a 2 minus 1, I get a square root of 1. And then if I plug in a 4, it won't work, but a 5 will give me 2. And there we go. So I'm kind of like trying to pick values of x that'll give me a pretty square root. All right, so that was f, and then G says write the domain, H says write the range. So we did f, sorry. G, the domain for this would be 0 included to infinity. The range for part H would be also 0 to infinity. Great. G, we have the square root of x plus 2. And let's go ahead and graph it. So that means we shift our square root function to 2. -2, sorry, because if I plug in a -2 here, I'd get a 0. If I plug in a -1, I'd get a 1. If I plug in a 2, I would get, well, sorry, 2 plus 2 would be square root of 2, so that'd be 4, yeah, 2. Okay, the next perfect square would be 9, so if I plugged in a 7, I would get a 3. Okay, so I'm kind of like making a table of value in my head. All right, so B, yes, this is 1 to 1. C, the domain for this would be -2 to infinity. D, the range for this would be 0 to infinity. E, we need to find the inverse function, so let's just go ahead and flip it. So we're going to have x equals the square root of y plus 2. So that would be x squared equals y plus 2, or the inverse of x is equal to x squared minus 2. F says graph it, so if I have x squared minus 2, that would be down here. And there's no, it doesn't say to not use certain values, so we'll just go both ways. So if my, I'm just graphing. I'll explain in a second. I am graphing x squared minus 2, so the quadratic parent function shifted down 2. That is a review item. I'll try to post a video on that if that's confusing to you, but you could also just make a table of values and plug stuff in until you got stuff that landed on the graph. All right, we need to write the domain and range for these. For the orange, so the domain would be all real numbers, so -infinity to infinity, or just all real numbers. And then the range starts at -2 and goes to infinity.